This assignment, I used a data set that was a sample data set of Big Mart sales. So it's in essence a grocery store that kind of lists out the types of items they sell, the types of stores they're sold in, the location the stores are in, and it lists out a bunch of different kinds of characteristics of the data or of the items. So you have item identifier, as well as the type of item, low fat or regular fat. Then a categorical data. So there's some categorical data, as well as some numerical data in here. This is the max retail price for each item, and then over on the right side is the sales per location. So this would be the location, the type of store it is, how big it is, and when it was founded. And this would be the sales per location for the item listed. So that the data set I used was already split into test and then training data. So first thing I did with the training data was do some visualizations just to kind of see the different kinds of items, that might be sold most and that kind of thing. You see fruits and vegetables kind of have the most sales. Same thing with the pie chart. Try to see, which items take up the most percentage. I think fruits and vegetables are, again, the highest percentage as far as sales. And then you can kind of see if there's any correlation in the correlation matrix. Kind of see obvious ones, and then see item max retail price and the outlet sales kind of correlate pretty strongly. So that was kind of just to get an idea of the data. Then I wanted to clean the data, so I went in and used the missing value node and configured it to kind of use the median for numbers and the most frequent value for any string values. And then wanted to do a few different models. So the first one I did was a linear regression model. So I placed a learner here. I excluded the identifier in my configuration, the item identifier. And I did that for everyone, excluding the identifier. And then did the same thing as far as cleaning the data for the test data and put it into the predictor, and looked at the numeric score to see how it performed, an R-squared value of 1, so that's good. And then but when I kind of looked at the predicted data and compared it with, so I'll sort descending, and compared it with the file table, with the original test data set, saw some differences. So I knew that the R-squared value wasn't the best indicator of accuracy, because the test data, as you can see, doesn't have sales outlet sales. So I did some visualizations to kind of see if the same types of characteristics are in this data, and for the most part they are. You see fruits and vegetables taking up a larger percentage here of sales, but still they are the most dominant in outlet sales. And then again, I just did a histogram to kind of compare the two, and fruits and vegetables again are dominating. So the linear regression did a good job, but I wanted to look a little further to kind of try to see how the actual values of the outlet sales compare. So I used a simple regression tree predictor and model. So I used it here again. Kind of excluded the identifier. Then you can see here with the predictor. I looked at the output and it was a lot more similar, but I was still having trouble comparing value to value because, again, the test data does not have an original sales in column. So what I did was I joined two tables. So I joined the original training data, which has a outlet sales column, and then I joined that with the predicted outlet sales, and I configured that just to show the two columns, so the prediction of the outlet sales and the original outlet sales, and I applied that, and then I put that into the score. So as you can see, I can compared the predicted outlet sales and the original outlet sales, and I looked at the accuracy of that, and we had an accuracy of 100%. So as you can see, moving from the original linear regression to a simple regression tree improved the accuracy greatly, just because again, the highest kind of value we get with the linear regression is 5,000, and we know just by looking at the table of the original training data that the highest value is 13,000, so you know that they're not as accurate. When you do a score on this data, you do not get great accuracy. So just kind of played around with some different models, wanted to see if you could predict the output sales, and by joining the original training data and the simple regression tree predicted table, got an accuracy of 100%, so I think it went pretty well.